This is a pitch that I wanted to just talk about the different components to give everybody a little bit different and better understanding of what's behind the scenes in terms of the architecture of our game myMO, My Music Oasis. So I'll be talking about basically the different pieces in the game and the subsystems. And, this really applies to any MMORPG game that someone would want to make, but this is how we've implemented it. So I'm going to cover a lot of stuff, but I'm going to describe the game, the subsystems that we have, and almost all MMORPGs will have a version or some version of these systems. And we're talking about basic client-server architecture of a multiplayer game, how you discover people to play the game with, called matchmaking, your avatar system or the character in game, your presence, its appearance, animations, and so on. Talk about maps and the teleporting around from map to map, what's going on there. I'll be talking about menus and HUDs that players interact with to get things done in the game. The underlying inventory and that these maps access. For example, what clothes could they wear, what characters could they be, what animations can they play, and what databases and where we store this persistent data, and our strategies there, voice and chat subsystems. Talk a little bit about music performance elements since this is a music game, and then talk about how we distribute the game and how Steam plays with what we've done in Unreal. Well, to describe it, I mean, we've all seen it, and the game itself is built on Unreal Engine 4.27, and we use Steam as a way to distribute the game. So the game is the gameplay and the programming and the maps and 3D models that are in there use Unreal Engine, and the way that the Unreal Engine gets to a person's desktop to be able to play it is via Steam. And the way also we use Steam services, you'll see later on, in order for people to connect to be able to play the game together. It's session-based, and by session-based, what that means is that someone decides that they are going to host a game, and they become what's known as a listen server. A lot of games work this way. So they become the server now, and then everybody that joins that game joins their server on their desktop to play. There's other ways to do this, and we'll be exploring those later, but you could have a persistent game, persistent server that's always running, and we'd run that on some kind of game servers like AWS has, or there's also other ones like Photon. But we have a simple session-based listen server implemented. There's also a bunch of services where you can buy that says, I want to run my listen server not on my desktop, but on another piece of hardware on the internet. And so you can actually say, run my game not on my PC, but on something that's beefier up on the internet. And you can buy that service just like you'd buy a web hosting service. You could buy a service for that. To play the game, someone acts as a host, which means, again, that their desktop launches a server and lets people join it to play the game with them. It uses what's known as a client-server architecture. And basically, what does this mean? I mean, basically, the server is in control of everything. And the client, as you can see over here, basically what the client does, if you're client one, you report your state changes. So you report, as you're playing the game, what you are doing. So it reports you're moving, where you're moving from spot to spot. Have you collided with something? Have you pressed some keys? Have you done some interactions with the HUD or the menu system? So whenever you do those things, those actions, you send that information onto the server. The server then's got gameplay logic that says, oh, I got this information from client one, and passes the appropriate information onto client 2. Like client 1 has moved from here to here. Yeah, has moved from this position to that position. Client 1 has changed its animation. Client 1, so client 2 then client 2 has a copy of client 1's avatar down on their desktop, and it will change its animation or change where it's moved to on its copy, because the server told it to. The server said, client 1 is no longer here, it's over here. So those two avatars are running on that client are, in terms of the being able to see both of them, because he's playing the game. But basically what's happening there, the server is telling each of the clients what the other clients are doing, and what that client should update on their client to represent the state of the overall game. A little bit confusing, but that's kind of what's going on. So all the client does is, like I said again, it doesn't do the processing. What it does is it reports state changes of its client. And then it does do, as an aside, it does do a little bit of actually the movement. For if you move your character in client 1, your character, the client takes care of moving your own character on your client. It doesn't wait for the server to come say, hey, I'm moving my client, client 1's moved, so now you can move client 1. Well, client 1 already knows it's moved, so it goes ahead and does that locally. And that also gives the interaction that's very quick. If you're walking forward, that means you walk forward instantaneously. Now, what happens though is client 2 may see you walk forward not at the exact moment you start on your machine, but within, X amounts of milliseconds later, it will start executing your character moving forward. So each client is slightly behind the original client, the movement, or changing the avatar clothes, or changing its animation. Not enough usually to ruin gameplay. And so you'll see, like, a good example of that is if it's a game that's shooting. If you're shooting on client 1, you will start shooting, you'll see your bullet leave, and the tracing, or like a ray trace, right away. So you get that interaction. That may not show it on another client's machine till milliseconds later. So it doesn't affect gameplay, but it is slightly behind the original client's movement. So that's what's going on. So basically, the server's really busy. The server's busy because it's telling all the other clients what each client is doing, and telling you what to do in response to that, telling that client what to do in response to it. Server's in control. That's the way you always look at it. So what are the components? We're going to start with matchmaking. Matchmaking is how people get together on the internet to play this game with each other, or any multiplayer game. Right now we're using Unreal's online subsystem, so component instead of Unreal Engine, that connects to a Steam service, an online service. And so the Steam service is the one that's really hosting and joining the game and getting the players together. So we're using their Steam login to join the game, the Unreal game that's running on a person's PC as a server, as a host server, listen server. So a player starts a game. The player selects to host the game on their PC. This, again, launches that listen server on their PC, and it also launches a client. So on the person that's hosting, actually it's got two pieces of software running. The server, which is doing, handling all the traffic of what's going on all the different clients and what those clients should react to do based on what those all the different clients are doing. And then it also launches its own client. So it's got two things going on there. It's got its client, and it's got the server running on their PC, on the host's PC. It registers that new game, and that's called creating a session. And basically what is a Steam lobby. So it says, hey, there's a new game made called Music Oasis Dance, and here's where it is. And if a person goes out there to discover what games there are, a person will join or log into myMO, and they'll say, I don't want to host a game, I want to join a game. And it goes out to these lobby areas and say what games are available. And whoever has hosted a game will show up on a list of games that are currently running, and or basically servers that are up and running. And then the person that wants to join the game chooses one of those, and what it does is then it connects through Steam to that other person's server. It knows where that server is. It knows its IP address. It finds it, connects it to it, and so all the people that are in that game are connected to that host listen server. That's called matchmaking, and that's how we do matchmaking. There's the avatar subsystem, and by avatar you hear it called many things: characters, figures, and so on. Basically, we have what's called a common figure blueprint. We have basically here's anything a basic figure or avatar needs, and inside of this data structure, that's all it really is, and blueprint logic, it's got a skeleton to use, and right now we're using 2 skeletons. We've actually have 3 out there. We have a poser skeleton, a DAS skeleton, and a RPM skeleton that we base our characters on. It's got a skeletal mesh. A skeleton is the bone structure and the relationship of the bones to each other for applying animation to. Skeletal mesh itself is the actual mesh that is weighted on top of that bone structure. And so you could have one skeleton, like RPM, that might have 30 different meshes associated with it, or 50, whatever. The meshes are, there's only 3 skeleton types, and there's a ton of different meshes, because the meshes is how they appear. And so a different mesh would have different features and different textures applied to it and so on, so it looked like a different character. There's other meshes associated with the skeletal mesh in terms of what it'd be holding in its hands, maybe what it's wearing, a hat or something like that. It's got the deformations for morphing. So what that is on some of the character sets, on the DAS poser base character sets, I'm using their functionality where they've weighted vertices against parts of the mesh, and so you could change the person to have a bigger nose or bigger lips or a different body type, or bigger feet. Basically what it does is it just acts like a magnet that pulls those vertices based on slider switches, which is very common amongst character animation or character customization techniques. So we use that for at least one of the character sets. We use a default, and it also identifies in the common figure blueprint which default animation to use for a walk cycle. And it's also got slots in that for changing animations for things like dances and so on. So it's basically the data structure associated with any character, regardless of the underlying mesh, skeletal mesh, or skeleton that it's using. So this would allow us to add metahuman or whatever else to the gameplay by just changing skeletal meshes and skeletons. We have a bunch of gameplay classes. What that means is inside of the game, everything and every function and everything you do is based on C++ classes. The C++ classes, just as an aside here, you can write everything in C# or in C++ as in classes, and just normal C++ classes to access various parts of the Unreal Engine API. Or you can use blueprints. And what blueprints are is just a visual scripting language that sits on top of C++ and compiles down into C++. So, and then into the actual binary. The advantages of both are C++, you've got every detail that you can want to do to affect the API. You can even go into the underlying Unreal Engine code in the engine and change to C++ if you want to, although that's bad programming practice. The The blueprints, again, are wrappers or visual elements that wrap various parts of the API and allow you to do logic inside of a visual scripting language rather than writing in C++. But it actually, like I said, it just sits on top of C++. So we use both in the game. The C++ is used in the part of the game that's associated with matchmaking and creating sessions and managing that type of stuff. So the very interfacing to other things type of processing. I'd also use C++ if I have a performance issue and for some reason I couldn't get the code tight enough using the visual scripting language. Although you don't usually run into lots of problems with that because it does compile it down before the game is played. So it's not like some scripting engines that say interpret it in order to, during the gameplay. It's already, before you play the game, it's already all sitting down and it's compiled C++. Basically, the blueprint editor is nothing more than a source code editor. You have to, in order to do a multiplayer game correctly, you need to make sure that you've packaged your game up into the right classes, because different classes have different access to different pieces of the API and are run on different places. Some things are run on the client, some things are run on the client and the server, some things are run on the server only. So you have to be very aware of that as you're writing the game and call the correct classes, call the code in the correct classes. So basically in our classes we have a player controller class, which basically a player controller is the interface to the human being and who's controlling it. So you can think of it, it's that mouse and WASD and joystick or whatever else they use to control the game. And in its approach, what happens is that controller goes ahead and the player controller possesses a pawn. And the pawn, known as a special type of actor or class, a pawn is the avatar. So you say, my controllers on my keyboard are controlling this avatar. So that's what a pawn is. A pawn is the avatar. So you select that. So when you change your avatar, what you're doing is you're saying, I want my controller now to possess a different skeletal mesh and skeleton, and and it becomes known in the game as a pawn. It is the movement of the avatar in the game is controlled by the player, obviously that way, and so they can move the character around using the key, whatever they've set up to control it. And you can use mouse, joystick, and you set that up in the project settings. Player state is a state is basically saying this is run on both the server and the client, and the server keeps the player state updated on each client, and it keeps the player state of all the characters of all the players updated on all the clients. So the player state is where you keep control of things associated with the player. So here's where I keep track of its appearance, what it's wearing, what it's interacting, where it is, that type of thing is done in player state. And if you had other elements like the health of the character, or, energy, that kind of stuff, you would do in player state. Game state is the state of the game, so it's one level higher, and it keeps track of like there's an overall score of the game. If it was a game that we're keeping score, we don't do a lot in game state. The only thing I do in game state is keep track, and that's where I have my spawning of characters when they change things, because it's something that everybody has to know about. So it exists on all the server and all the clients. And then there's game mode. Now game mode are the gameplay rules that don't change or are not affected by players, clients moving around. So it would be the kind of data structures that you would expect to be static throughout the game. And it only runs on the server. And then game instance, which is only running on the server, is the actual session we talked about that got established in the matchmaking. So it's very important because you can build a game, especially a single-player game, not a multiplayer, but a single-player game, and only do everything in the level or in the player controller. But if you're going to build a multiplayer game, you've got to make sure everything is segregated into the correct classes. And here's another example of what the classes are and how they interact with each other, with a player controller possessing pawns. Now, besides player controllers, we have NPCs, and if it's an NPC, an AI controller is possessing a pawn. But so they're using the same mechanism to control and move a skeleton and skeletal mesh, whether it be a person with WASD keys or logic in an NPC. And in a player controller also has other things associated with it. It's got, it can interact with menus and do other things like chat and voice and so on. It's got a camera manager, which we utilize as well. We have a camera system inside of our game. The gameplay in the client-server game, a player interacts with a game on client. Again, we talked about this before. He moves it, he collides with things, he chooses items from a menu, he does, whatever. And in the case of the movement of the client, it moves the actual avatar on the client, but it also it sends a message to the server saying, I'm moving. And then the server says, send that information to all the other clients so that they know that character, the client has moved, the client one has moved. This process is known as replication. Some replication can be controlled via settings in the actual Unreal game for things so basic as movement. You just have to say, I want you to replicate all the movement. So basically it says it replicates that you've pressed the W key down and held it for 5 seconds and moved from this position to that position. It sends that automatically. You don't have to write code for it. A lot of other replication in our game, especially things that you're selecting from a menu, or you're colliding with items, or whatever, that type of thing, you have to write the code yourself to handle it. So, for example, if I on my DMX lighting, if I turn on a spotlight and start spinning it, I've got code that tells every other client to better start spinning your spotlight so it keeps up with what the person that's the host has done. The other subsystem that's worth talking about again are those user interfaces. So there's menus. There's a menu system in the game. And the menu system, again, the client's interacting with, and then it sends its information that it's clicked this button to the server and the gameplay logic, and the server says that means this has to happen on all the other clients. But there's 4 main menu areas. There's the login menu, and main menu, the gameplay menu, and the music applications menu. The login menu, basically, you say, I want to play the game by myself, which is called solo. I want to host a game, which we've talked about what that does, starting a listen server so people can join and establishes your session and put yourself in the lobby inside of Steam so other people can discover you. If you're joining the game, it looks for what games are active in the lobby, and you can join them, so you connect to their server, and you can quit the game, which just exits the game completely. That's the login menu. All the login menu and all the code associated with all this login process and the session and stuff is written in C++. I've got it written. That's the way I decided to implement it, because I have more control than I would if I tried to do it in blueprints. It calls the underlying subsystem, online subsystem in Steam for the matchmaking, and as we said before, it launches the server, the listen server, and it travels to the starting map. The main menu. And the main menu is the one that's at the top. It allows you to exit. You're in the game then, so you're walking around with your avatar. And exit doesn't exit the game. It takes you back to the login menu. So you can go, discover another game if you want to, or you can just quit the whole thing. So you have to, if you're going to leave the game, you quit twice. You can chat. You can, and when we say chat, that just toggles on the chat Subsystem. Yeah, the box shows up for chatting, and if you toggle it off, the box goes away. The chat system is all written. It's code I wrote, so I'm not using any plugin or anything for that. I wrote code to do chatting using replication. The voice button on the menu on the top toggles on and off our voice, and we're using a plugin for that, and we're using Epic's voice over IP. And the help just launches a help website. And again, chat system is homegrown, and the voice system uses the Epic Online VoIP. The game menu, basically in the game menu is the one that's on the right-hand side. And with that, you can change your avatar. You can morph your existing avatar, change the way it looks. You can change its animation it's using. There's a bunch of settings you can change, and those are the normal game settings for things like which microphone to use, what the level of the volume is, the type of normal kinds of settings that you would have with the game. You can change its outfit or clothes. Right now, I used to have it so you could change individual pieces of clothes, but I couldn't get that layered clothes system to work without the character walking out of their clothes. Because of replication, because basically by the time it told everybody, this character is moved and all its clothes is moved, what happened is that they didn't stay synced up, and therefore it looked like you're walking out of your clothes. With a straight up replication system, couldn't control that. So we'll find some other way of doing that eventually maybe, but right now what you do is you go to that same menu system and you pick full outfits. So instead of being able to swap tops and bottoms, you say, I want to wear this outfit that's this top and bottom, this hair, so on. You can place props. That's not implemented yet, but we will. And basically that says you can select a prop, a chair, or it's known as backpacking inside of Sansar. You have a set of objects that you can place into a scene based on whatever the rules we have in the gameplay for those scenes. And whatever permissions you have to be able to do that inside of that scene. You can change cameras, make them first person, third person, free camera, and so on. You can launch different music applications, and they're still being built, but loopers, riffers, and so on. Just different ways to interact, playable pianos, that type of thing. You can teleport to another map. The gameplay menu sits on top of an inventory system. That's important. So basically all the elements that you see in the menu, they're not part of the menuing systems. They're from a database and a menu and a set of arrays that have all those elements in them. So if I add a new outfit, I don't change a menu system. I just add something to a database, or in this case, an array inside of the game. The last, again, is music applications, and it's got things all ready to control DMX lighting, for DJ type lighting, change the video or audio that's playing inside of the game, so you can bring in DJs from the outside with their music, in-game loopers, riffers, so you can make music in the game. I'm working with the Endless guys to do some stream capture, which will allow people that are doing Endless, which is a piece of software, jams, to play together, and the resulting audio will be streamed into the game, and then who knows, playable music instruments. We'll see where we go down the road with music applications. This is built mostly for musicians, so a lot of that will have to do with what people find interesting. Last thing I want to talk about is persistence. Well, not the last thing, but the last thing in this area. And persistence basically is saying, how do I remember things about the game? Or have session level persistence, and basically that's, as a game is playing, it keeps stuff in player state and game state variables, as I talked before. So these classes, have they know their state. They know what outfits are being worn and so on. When session persistence, when the game ends, all these variables go away and are set back to their default. I have local persistence. Local persistence is what's stored on their hard drive. And this would be like if we had maps that were downloaded, it would keep track of which maps were downloaded or not downloaded. So, or they added, right now the inventory system is tied to the machine. So anything that says it's tied to the specific machine they're on. The last one is global persistence, and what we use now is we use AWS. I store, like for example, the character's last or current avatar appearance, information about what they look like and what they're doing is stored in that database. So the next time they get on, it remembers what their avatar they were using was. So the last avatar appearance chosen. And we'll also be using it for when they add inventory. Right now, if they add inventory, it's stored locally, but I want to go ahead and put that in the game. So if they move from their PC to their desktop and they're logged in as the same person, all that stuff's available to them on both PCs. So we'll move it from local to global persistence. Other considerations. Well, first of all, you have to decide how to, once you've got a game done, how you want to distribute it and how you want to keep everybody updated to the same copy of the game. We use Steam. We're using Steam pipe distribution and differential patching for the most part. So basically, it'll be like every other Steam game you get. If there's a major update, you'll be asked to update your game. If there's a minor update, you'll be asked to update your game, but it'll be much faster. And that's what differential patching is. That says it doesn't make you download the whole game. It just makes you download, the changes that were implemented for this game or for the latest little patch. And so we'll do the same type of things in terms of major releases and minor releases, or the minor releases will just be patches, and the major releases will be you got to download the whole game again to get back in sync. AWS S3, we've got we implemented something we probably won't be using a lot to start with, but will certainly be a big player in the next version of the game, which would be the game that's the creator version of the game. And it's the fact that we are storing the maps up in S3, and what will happen is if you don't have that map downloaded, it'll grab it from S3 and bring it down into your build. And this is intended for not core maps, but for when other people started creating maps that weren't part of the core team, and they had their own club they built or their own thing. And in Unreal Engine, they used our template in the future that will allow them to store it out in S3, the resulting map that they build, and we'll grab it from S3 and allow people to use it. There's a community aspects of the game, and what we're using is Steam pipe tools. So we have which you can get to by doing, like most Steam games, with a Shift tab key, and it gets you to friends, group chat, news, guides, screenshots, community hub, discussion forums, basically all the tools that you'll see in almost all Steam games. We'll have our specific ones for myMO in there. And here's an example of what that looks like. If you hit Shift, you're in the game, you hit Shift tab, and you're brought into the overlay from Steam that allows you to look at your friends, look at your group chats, look at your news, guides, and all that junk. We also will have a website that will be somewhat loosely integrated with the current one we're setting up for Music Oasis Omni. We'll have Discord channel, a YouTube channel, Twitch, and Facebook probably, and maybe others. We haven't really fleshed all that out. In-game purchases, initially we're not doing anything with it, but the basic approach we'll take to it is we'll have certain inline purchases that we got to figure out how to do it with what I'm calling controlled by the application. It means it's really downloaded on the user's desktop as part of the game distribution, but they have to unlock the content with something. By paying something through a payment system would be something we would do. We'll probably use some of this too for encouraging people to play the game and do stuff, and if they earn certain points that they would be able to get certain things like new outfits. We also may use Steam DLC, which is again a Steam's version of saying, do you want to add to the game instead of just as a patch? You want to add something that's an addition, and the addition is going to cost you so much money, you got to buy it. So it's like buying a game, but it's tied to the existing game. So it's buying an upgrade to the game. And then there's a Steam store as well, where we could sell items as well that are may or may not be tied to in-game, but are maybe, T-shirts and junk. So that's it. That's kind of where I was at with this. I just want to give everybody kind of a view of what MMORPG, what the pieces are usually, and what they are specifically in myMO. If you made it this far, I congratulate you listening. Thanks.